Welcome, Maths Mastery Academy, to this video on reciprocals and cross-cancelling. So I'm just going to run you through some notes that I took first, and we'll do a couple of examples together in this video. So if you don't know what a reciprocal is or what cross-cancelling is, don't worry. It's a very useful technique for simplifying fractions and multiplications of fractions. So one case, the way you may use it is, suppose you're solving the equation 3/8 x equals 7/20. Now, I was doing this with a student the other day. There's a few more steps in this equation. This is what we ended up with. And they were stuck. They didn't know what to do next. So we went through a couple of ways to solve this. So one way to get 1x, we could start by multiplying both sides by 8 to get 3x. So 3/8 x times 8 will give us 3x. And 7/20 times 8 is 56/20. And then we could divide both sides by 3. And then simplify the fraction. And this is good. But what if, with a good understanding of maths, you could do this in just one step? That'd be pretty useful, right? So for that reason, we are going to introduce reciprocals. So two numbers are reciprocal if they multiply to make 1. For example, the reciprocal of 5 is 1/5, because 5 times 1/5 equals 1. Equally, the reciprocal of 1/5 is 5. So those two numbers, we could say, are reciprocal to each other. The reciprocal of 2/3 is 3/2, because 2/3 times 3/2 equals 1. So since in our equation up here, we want to find what 1x is equal to, if we want to do this in one step, we could multiply 3/8 x by 8/3. Notice you're basically doing what you did here, multiplying by 8, dividing by 3. You're doing the same thing, but you're doing it in one step by using the reciprocal. So we get x is equal to 7/20 times 8/3. So now we're just multiplying fractions. This has just turned into a multiplying fractions question. And before we dive into multiplying the fractions together, let's step back and think. Working with smaller numbers is easier than working with larger numbers, but it's pretty straightforward in this case. You always want to look for common factors in the numerator and the denominator to make your multiplication easier. So here we could actually prime factorize the numerator and the denominator. So 8 we could split up into 2 cubed, or 2 times 2 times 2. So the numerator of our fraction is going to be 7 times 2 times 2 times 2. The denominator, we've got 20, which is 5 times 4, or 5 times 2 times 2. So again, we've prime factorized 20 into 5 times 2 times 2, and we're multiplying that by 3. Since we've got two factors of 2 on the numerator and the denominator, we can cancel them before we do the multiplication. Cancel the 2's, cancel these two 2's, because that's the common factor on the numerator and the denominator. Now there's no common factors, 7, 2, 5, and 3. Now it's a very easy multiplication to do. Easy to do multiplication with smaller numbers than it is with bigger numbers. Even though 7 times 8 and 20 times 3, you'd be absolutely fine working out, I know. This way is very helpful as well when you do have, maybe it's 18 times 21 divided by 15 times 27, for example. You don't want to do all those multiplications because there's so many common factors on the numerator and the denominator that you could cancel out first. It's a pretty great method, this one. And you should always use prime factorize the numbers on the numerator and the denominator and cancelling all the common factors. Prime factorizing is just a fantastic maths technique, which is just so often useful, and you should get really comfortable with it, because in the Maths Mastery Academy, we do prime factorizing of numbers a lot. It's a really important problem-solving technique. You can make this process even quicker. So you may notice with 8 and 20, they both are multiple of 4. So since we now have a common multiple of 4 on the numerator and the denominator already, we could just divide both those numbers by 4 straight away. So dividing 20 by 4, we get 5. Dividing 8 by 4, we get 2. And again, you're doing the same calculation. 7 times 2, 5 times 3. So that's why it's kind of called cross-cancelling, because you're looking for the factors, the highest common factor of the two opposite numbers in each fraction on the numerator and the denominator. Now we're going to do a couple more examples, and I'm just going to switch over to my iPad so that I can work through them with you. Okay, let's dive into some simplifying and multiplying fractions. So the reason I've included a couple of simplifying questions before we do the multiplying fractions questions is just so you get used to the idea of cancelling down fractions and what is actually going on here. Now, if you look at this first example, 100 divided by 125, you probably notice they're both multiples of 25 because we have a common factor of 25 on the numerator and the denominator. We can just divide the numerator and the denominator by 25. What you may not notice is that it's because if we factorize, we prime factorize 100 and 125, we get for 100, because it's 10 times 10, 10 is 2 times 5, it's 2 times 2 times 5 times 5. 125 is 25 times 5, or 5 cubed. So 5 times 5 times 5. And then we cancel all of the common factors. There goes the 5s. We're just left with 4 over 5. So of course, in your methods, normally what you do is something along the lines of 72 over 120. Well, that's got to be 36 over 60. So we divide by 2 again to get 18 over 30. We divide by 2 again to get 9 over 15. We divide by 3 to get 3 over 5. And now it's in its simplest form. What you're doing in 4 steps there is what you could also do by saying, well, 72, well, that's 12 times 6. So that's 2 times 6 times 6, or 2 times 2 times 3 times 2 times 3, or 2 times 2 times 2. Is that the right number of 2s? Yeah, times 3 times 3. Divided by 120, which is 12 times 10. So that is 12 is 2 times 2 times 3. 10 is 2 times 5. So it'd be 2 times 2 times 2 times 3 times 5. So basically what we're doing, we divide by 2, we divide by 2, we divide by 2. That's the same thing as cancelling. 3 2s, the common factor of 8 on the numerator and the denominator. Dividing by 3, cancelling the common factor of 3 on the numerator and the denominator. So that's what's going on here. Now you may notice 2 times 2 times 2 times 3 is 24. 72 and 120 are both multiples of 24. If you spotted that straight away, firstly, that's very impressive. And secondly, you could just divide by 24, which is the highest common factor, straight away. If you need to prime factorize to work out the highest common factor, though, it makes sense just to do the prime factorization, and rather than working out the highest common factor, just cancel all of the prime factors in common. Now lastly, 45 over 120. So obviously they're both multiples of 5. So we could just divide by 5, see what we get, see if we can spot another common factor. We may, just going to move that. We may wish to prime factorize, though, to try and maybe spot this a little bit quicker. So 45 is 9 times 5, or 3 times 3 times 5. 120 is 12 times 10, which is 3 times 4, or 3 times 2 times 2. And again, we can see on the numerator and the denominator, we've got a factor of 3, we've got a factor of 5. 2 times 2 times 2 is 8, so we're left with 3 over 8. I'm not suggesting you do this every time. Often it will just be quicker just to spot the highest common factor. If you can do that, that is a skill. Working with factors, working with prime factorization, it is a skill that is extremely important as you go through mathematics, as you get older, as you're working with numbers, basically. So it's good to get into these habits now, understanding not just how it works, but also what are the different methods you can take in different situations to solve a question like these. Now, it's particularly useful when we're multiplying fractions as well. So for a question like this, oops, let's get rid of the answer. 15 over 28 times 7 over 10. We may split this up. 15 is 3 times 5. 28 is 4 times 7, or 2 times 2 times 7. And then we're doing 7 is prime. 10 is 2 times 5. So we're doing the same thing as 3 times 5 times 7. Because when we multiply fractions, we multiply the numerators, and then we multiply the denominators together. And 2 times 2 times 7 times 2 times 5. Now we can cancel the common factors. Get rid of the 5s, get rid of the 7s, and we're left with 3 over 8. So this method will always work. It's very practical. It's relatively efficient. There is a slightly more efficient method, which is the more formal cross-cancelling technique, where you look and say, well, this is a factor of 5. This also has a factor of 5. So we're just going to divide them both by 5. 15 divided by 5 is 3. 10 divided by 5 is 2. 28 and 7, we could divide 7 by 7 to get 1. 28 by 7 to get 4. Again, it's really helpful if you can just see the common factors between smaller numbers, see that two numbers are both a multiple of the same number and divide through by that number. If you haven't developed that number sense yet, in order to see what the highest common factor between two numbers is, then doing the factorizing, the prime factorizing method is really, really useful as an intermediary step while you are learning more about numbers themselves. So of course we do 3/4 times a half now, we get 3/8 as our answer. Now 64 times 7/8. 95% of the year 7 and 8 students that I start teaching, as their first step, would do 64 times 7 and then try and divide it by 8. This is not a practical approach to this question. What you can do is spot 64 is 8 times 8. That's going to go into the numerator of the fraction, because you could think of it as 64 over 1. Multiplying the numerators together, 64 times 7, multiplying the denominators together, 1 times 8. But we've got an 8 on the denominator as well, which we can cancel. So this is just equal to 8 times 7 divided by 1, which is, of course, just 8 times 7. You get 56. There's a much easier approach to this question if you divide by 8 first before you multiply by 7. So, of course, I don't want to give you a general rule like always divide first, because there will be some cases where that won't work practically. When you're working with fractions, it's often easier to divide by the denominator first before multiplying the result. We look at a couple more of these questions. A half times 5/7. Now, there are no common factors here between the numerator and the denominator. So we can just write that as 5 over 2 times 7, which is 14. So we can't use the cross-cancelling technique there because there are no common factors. And 5/14 is in its simplest form. Now 13 over 38 times 19 over 26. What are the common factors here? Give you a moment to have a think. Maybe pause the video if you want to. Now we're going to dive in. So 13 and 26 are both multiples of 13. So what we can do if we're using the cross-cancelling technique is divide them both by 13. 13 divided by 13 is 1. 26 divided by 13 is 2. 38 and 19 are both multiples of 19. Divide 19 by 1, we get 1. Divide 38 by 19, we get 2. So we end up with, by doing a half times a half, which is, of course, a quarter. Far, far easier than doing 13 times 19. I'll leave it how it is. By doing 13 times 19 and 38 times 26. Okay, that would take ages. And then you'd have to simplify afterwards. It's going to be really tricky, especially since the factors will be 19 and 13. So that one would be almost impossible to do if you multiplied it out first, unless you know some divisibility rules for 13 and 19 that I don't, in which case, tell me. Cool. Question 5. So again, we're going to use the cross-cancelling technique. What are the common factors between 9 and 3? What are the common factors between 2 and 14? So we can divide 2 and 14 by 2 to get 1 and 7. We can divide 3 and 9 by 3 to get 1 and 3. We get 1 over 1 times 3 over 7, which is just 3 over 7. And finally, 16 over 21 times 11 over 12. What are the common factors there? 16 and 12 are both multiples of 4. So dividing them both by 4, we get 4, 3. Now there's no common factors between 11 and 21. So we do 4 times 11 is 44. 21 times 3 is 63. And because we already checked and there's no common factors between the numerator and the denominator, we can say with certainty that 44 over 63 is in its simplest form. And if you don't believe me, what you can do is prime factorize the numerator, prime factorize the denominator, and you will see that there are no common factors on the numerator and the denominator. I hope this was helpful. Let me know below if you have any questions.